This is the video answer key for Unit 1, Lesson 4, Scott's Workout. In this, Scott has decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the given bar graph, with day 1 showing he completed push-ups. After 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. How many push-ups will Scott do on day 10? So the first thing I want to do is mark up the bar graph. So I'm going to go ahead and highlight a few things. The first thing that I'm going to highlight is kind of the increase per day. So it looks like at day 1, he's got 3. And then it looks like it increased by 2 right here, so that he has on day 2 5 push-ups. And then it looks like he increased here on day 3 with another 2 to make it 7. And then it looks like again he increased by another 2 right there to get 9. So it looks like that is our pattern that we are adding to each day. Now I'm going to color in a little bit more to help visualize what's going on. So I'm going to color in this addition that was on the second day on there, and then I'm going to color in what he did on day 1. It was this 3 that was the initial day 1. So in order to find how many push-ups he does on day 10, looks like we just need to continue the pattern on to day 10. So I'm just going to list it out. So day 1 is 3, and then we go 5, and then 7, and 9, and then 11, 13, 15, 17, 19, and day 10 is 21 push-ups. And that we just get by adding 2 over and over until we get to day 10. Our next task is to model the number of push-ups Scott will complete on any given day, and we need to create a table, a graph, and both a recursive and explicit formula. So let's do our table first. In our table, the X values, like what we're plugging in, is the amount of days. So I'm actually going to call that D for days. And the Y values, what we're getting out, is the number of push-ups. So I'm going to use function notation here and call Y P of D. Okay, that way we know this is push-ups per day, and then what we're plugging in is days. So let's fill in a few of our values. So day 1, we had 3 push-ups. Day 2 was 5. Day 3 was 7, and I think we'll just stop there. When we graph this table, down here is days, and over here is push-ups. And then I think we will just do a scale of 1, but I'll just label every second box so that it's not too kind of squished. Again, I'll do that same scale here, going by 1s, but just labeling every other box so that my labels are not crammed. Okay. So after 1 day, we're at 3. So 1 is right here, and that's 3. After 2 days, we're at 5. After 3 days, we're at 7. 4 days, we're at 9, and so on. So you can kind of see this, like the step going on I'll just use a highlighter to kind of show it. I'm not going to connect my dots because he's not doing push-ups in between 1 and 2 days, or in between 2 and 3 days. But you can kind of see that every 2 push-ups he does, 1 day goes by. Every 2 push-ups, 1 day goes by. So there's kind of this step thing going on. If we were to connect the dots, it would turn into a straight line. But we won't connect them because this is called discrete, where it's only happening at certain days. It's not happening continuously the whole time. Okay. All right, let's go ahead and create our 2 equations now. So we're going to do our recursive equation first. So the recursive equation tells us where we start, and then references to find the next term, it references the previous. So we're going to say we start at 3, and we need to recognize here that in the other lessons, the start was like what happened at time 0, but this is day 1. To finish off the recursive equation, we need to write how to get to the next term, so the next day. So we're going to write next is the previous plus 2. And in the takeaways, I'll show you how to write this recursive equation using function notation. But right now, I'll just leave it as that. To write the explicit equation, it's going to be our push-ups per day. So P of D equals, and now it's very tempting to say that we started at 3, so we're going to do 3 plus, and then 2 per day, so 2D. Now, if you write this, you're really close to the actual explicit equation. But what you'll find that if you use 3 right here, you're always ending up 1 too far. And I'll show you an example right now. So let's say we find day 2. So day 2 with this formula is 3 plus 2 times 2. That's going to be 7. But we plugged in for days 2, so we should have gotten 5 right here, right? So how do we adjust this equation right here so that we're not always going 1 spot too far? Because that's ended up happening, right? We didn't want 7, we wanted 5. So we are actually going to make an adjustment to the 3. So right here, we're going to make an adjustment to the 3. Rather than using 3, we're going to back it up 1 increment of the pattern. So rather than doing 3 plus 2D, so I'm going to cross this off. We're not going to use this. We're going to do 1 plus 2D. Do you see how our pattern is adding 2? So I went back 1 spot with our pattern. And this is kind of like if there was a time 0. If there was a day 0, then he would have done 1 push-up. But it doesn't really make sense in context. Like there's no day 0 and 1 push-up. But we need that in order for our formula to work. So if we test this now with replacing D right here with 2, 2 times 2 is 4 plus 1. That gets us the 5 that we need. Okay. So be aware if your sequence starts at the first term or the first day, that when you create an arithmetic explicit equation, you're going to need to back up 1 step in order to make your equation work. Otherwise, it's always going to be going one too far, one too far. The final question here says, what type of sequence is your model for the number of push-ups that Scott did, and how do you know? We know it's arithmetic because of the addition pattern. Okay, so we say let me change my font size. Arithmetic adding 2 each time. Okay, so that was the task for lesson 4, Scott's workout. I'm going to go ahead and move on to the takeaways now, where we're going to add a few more definitions and a few more notation. The first takeaway right here asks about a table and how finding the common difference in each representation of an arithmetic sequence helps. So for a table, we can find that common difference by seeing the difference between the terms, and it's just easy to visually see it. Okay, so helps find difference between terms. Okay. How do we find the common difference in the explicit equation? So let's rewrite our explicit equation for this situation. It was push-ups per day, so P of D equals 1 plus 2D. And we can see right here, this is where we have our common difference. It's right here in front of the variable. It's what we're adding over and over again, right? 2 in front of the D. So that is our common difference right there. Common for the recursive equation, let's go ahead and rewrite that. We had the start was 3. And we have the next equals the previous plus 2. Our common difference shows up right here when it relates the next to the previous. So that's our common difference. On a graph, how do we see the common difference? On a graph, we see it by seeing the slope of the line. Let's see. Find the slope of the line if or between the dots. And for our situation, it was plus 2 over plus 1. The plus 2 was up 2, the plus 1 was right 1. Okay, so these were 4 different ways where we were able to see the common difference for this arithmetic sequence. We're going to add a little bit more notation and then 2 vocab. So the notation that we're adding is to flesh out the recursive equation right here that we haven't really turned into function notation yet, so we're going to do that right now. So I'm going to rewrite that recursive equation that we created. So we have start equals some number, and then we have the next equals the previous plus 2. So if I were to use function notation for a recursive equation, it wouldn't say start equals. So it would actually tell me which term in the sequence is the 3. And so in this situation, it was P of 1. So the push-ups after 1 day. So this right here, we would replace with P of 1 equals 3. Okay, and then the next would just be P of D. So the push-ups on a certain day equals previous would be P of day minus 1, right? Because we want to go back 1 day, that's previous. And then we would have the plus 2 at the end. Okay, so the next is replaced with P of D, and the previous is replaced with P of D minus 1. So now you are up to speed as far as the recursive equation and using function notation for it. Okay, so the start in our situation was P of 1. Next, push-ups per day, P of D, and then previous, P of D minus 1. We're going to do 2 vocab. Our first vocab is independent variable. That's just the input, what we decide to plug into the equation. And the dependent variable is just the output. It's the answer that we get out. In summary, in this lesson, we modeled a real-world situation with a table, graph, and equations, both explicit and recursive. We learned the mathematical notation for writing recursive equations and how to identify the common difference in each of those representations, in the table, in the graph, and in the equations. I hope that this was helpful. I wish you luck on your check your understanding.